All right, volume of surface area applications. Word problems. Starting right off at number 1, the rectangular box has a surface area of 230. So surface area is basically all 6 faces, and we're trying to figure out, how much this length right here is. So when I'm doing surface area, one thing that I know is that I know that this end right here is 25, because 5 times 5 is 25, which also tells me that this end right over here is 25. So that's 50. So let's take away the 50 we have. So that leaves us with 180. And luckily, because this thing has a square end, that this bottom, right here, this area, is just 5 times L. And there's actually 4 of those. So you have this rectangle in the front, you have the rectangle on the top, you have the back rectangle. So we have 4 rectangles. So this is going to equal 4 times the rectangles. So if I divide by 4, each rectangle has to have an area of 45. Well, how do I get an area of 45? Length times width is 45. So it looks like the length has got to be 9. So if this is 9 times 5, I'll have 45 for all 4 of those, plus the ends. We will be good to go. Moving on down, number 2, the first of many number 2s. I stole these from a lot of different assignments, so I didn't change the number, I just grabbed them. So the volume of a square pyramid is 900. Find the side length of the square base. So since it's a square, I know that these two are the same. Right away, I start off with my volume formula. Volume of a pyramid is 1/3 base area times height. Well, they tell me what the volume is, so I'm going to plug in 900 for the volume. And I have 1/3. The base area I don't know. The base area is a question mark, but it's x times x, which is x squared. And the height I do know. This height is 12. So now I have an equation I can solve. So 900 equals, well, 1/3 times 12 is 4. Divide both sides by 4. And to get x by itself, I need to take the square root of both sides. And that gives me a side length of 15. There we go. Number 3, surface area of a cube is 384. Well, surface area of a cube is kind of interesting because it's a little bit easier than just a random box. Because if you're a cube, all 3 sides are the exact same. It's x by x by x. So if we kind of work this thing out, basically there are six faces, 6 squares, and every square is x by x. And that's got to come out to be 384. So I have 6 x squareds equals 384. Divide both sides by 6, and that gives me 64. Take the square root of both sides, which tells me x is 8. But now I can go after and I can find the volume. So if this thing is actually 8 by 8 by 8, the volume of a box is just length times width times height. And since they're all the same, I can just use cubed, and that number is 512. All right, number 4. Looks like we have a square pyramid. Height of the pyramid is 30. The height along the triangular faces, called the slant height, is 34. What is the volume? All right, so again, always start with your generic formula. Volume of a pyramid, since it's got a point, it's 1/3 base area, height. So the 1/3 stays there. The height is 30. That's nice. And the base area is what we got to figure out. So it's a square, but I got to figure out what these two numbers are. And basically what I'm going to do is I'm going to connect a line from the center to the edge. I'm going to make a right triangle because that's exactly half of the side length. So if I kind of put let's just call that x. If I kind of put my x in there, I can do the Pythagorean theorem. x squared plus 30 squared equals 34 squared, which is x squared plus 900 equals, I got to cheat and use a calculator for this one, 34 squared is 1156. So minus the 900 is 256. Take the square root of both of those, and we get an answer of, I think that's 16. Square root 256, 16. Oop, got ahead of myself. So if this is 16, that means that the side is twice that big. So we have a 32 and we have a 32. So for my base area, it's 32 times itself. So let's kind of jam all this stuff in. I'm going to do some of this in my head. You know, 1/3 of 30 is just 10. And then we have 10 times, well, what's 32 squared? That's 1024. So just add a 0. 10240 would be the correct answer. Matches up with my sheet, so that was nice. All right, things get a little tougher on the next page. So number one, the new number one, is you have a cylindrical ring that's 20-inch diameter with a 14-inch hole. What is the volume of the ring? So this is kind of like the composite area stuff when we did chapter 9. But I'm basically going to have the volume of the big cylinder minus the volume of the ring that we cut out. All right, so we're subtracting the two cylinders. So the big dog, volume of a cylinder is pi r squared h. Same thing for this one, pi r squared h, but they both have different r's. So the big dog has a diameter of 20, so the radius would be 10. So I have pi 10 squared, h is 6. And then the smaller one has a radius of 7. So that's pi 7 squared times 6. So over here we have 10 squared is 100 times 6. We have 600 pi minus 49 times 6 is 294 pi. Subtract those, we have 306 pi. And when you multiply that out, you are somewhere in the neighborhood of 961.327. But it says nearest whole number, so we'll just call it 961. All right. Number 2, this one's probably the toughest one, I think, on the sheet. I know I went over this in most classes, but I'll kind of hit it again. So you have a cylindrical block of cheese with an 8 centimeter radius. So a couple things we need to know. We have radius of 8. We have a height of 6. It's cut into thirds, equal thirds. So this is 1/3 of the full cylinder. All right. And then it says, what is the volume and the surface area round to the nearest whole number? Make sure to include the entire surface when you're doing surface area. Well, volume's easier. Let's do volume first. The volume of a cylinder is pi r squared h, but this was cut into thirds, so it's a third of that. So we have 1/3 pi r squared h, and I can clean that up a little bit. 1/3 of 6 is just 2, so 2 pi 64, which is 128 pi. So when I crank that out, somewhere in the neighborhood of 402.123, or 402 point, well, I guess if we got to round it, it's just going to be 402. All right, surface area. Surface area is a little bit trickier. So some things we need to know. One thing I want to talk about is when you look at this block of cheese from a top view, all right? So this is from the top. What we are interested in is, it's almost like the peace symbol. If you cut it into thirds, we're interested in this area right here, how much that is, because when I do surface area, I have a top, and then I also have down here at the bottom, I have two of these weird partial circle areas. So I have two of those. So let's kind of try to figure out what the area of this would be. And I think if we're looking for that little thing, it's the area of a circle divided by 3, or times 1/3. So you do divide by third or times by 3, whatever you want. And since this is 8 for my radius, so one of these is going to be 1/3 times pi times 8 squared. But then we got to remember we have a top and a bottom. So I need to double that. I need to do 2 of those. So let's kind of crank this part out. I think I have that here. I think that is 134.04. So that's for our top and our bottom together, because I times it by 2. So we got this piece. Now we got to knock out the rectangles. So if we look at the rectangles, we have a 6 by 8. All right, 6 times 8. But then we have 2 of those. You know, this is also 8, and this is also 6. So we have times that by 2. So it looks like we have 96 for those 2 red pieces. So I'm going to add over here a 96. And then the last thing we got to kind of calculate here is we need to figure out, kind of get rid of these colors, we need to kind of figure out this back piece. That is this rectangle. It's kind of bent looking right now. But we need that rectangle. So that rectangle has a height of 6. But this is where it gets a little bit tricky. We need to figure out what the length of that is. Well, the length of that arc is right up here, which is actually 1/3 of the full circumference all the way around the circle. All right? So we need to know the equation for the circumference of a circle, which the circumference of a circle is 2 pi r, and we want 1/3 of that. So we need 1/3 of 2 pi r. So that one's going to be a little bit kind of weird. Actually, not too bad, because when I multiply base times height, and I times these out, the 6 and the 1/3 are going to cancel. So that's going to be 2 times 2 is 4 times 8. That's going to be 32 pi, which is roughly, I don't know, let's just crank that out, 32 pi. It's about 100.53. So I add that into the mix. And we get a grand total at the end of all that stuff. I got 330.57. So if we round it to the nearest whole number, I'm thinking 331 is the surface area. That problem was pretty involved. That's tough. That's no joke. All right, moving on down. Number 3, we have this weird ice cube shaped thing. And it says it's a rectangular prism with a cylindrical hole. Calculate the volume and the surface area. Round all the answers nearest whole number. So volume is always easier. It's basically going to be the volume of the box. But that would be too much. Then we got to cut out the cylinder. So volume for a box is just length times width times height. Volume of a cylinder is pi r squared h. So length times width times height is 30, 30, 15. So 30 times 30 times 15, which is 915. I think that's 13,500. And then we need to take away from that pi. Well, what's the radius? The diameter is 20. So that means the radius is 10. So we have pi 10 squared. Height is still 15. So that's 1,500 pi. Punch that into my calculator. It looks like it comes out to about 8788. So there's the volume. That's V. Surface area is going to be a little bit tougher. It always is. So let me just kind of get the pieces for surface area. Start off with the easy ones, the rectangles. So these 4 rectangles, all the way around, there's 4 of them, front, back, right, left. So we have 4 rectangles, and every rectangle is 30 by 15. So that gives me, what's that, 450 times 4, which would be 1,800, I believe. So we got that. Now we need the top and the bottom. So these were the walls. So now when we do the top and the bottom, we basically have a square with a circle cut out of it. So we're trying to find that area. And we got to remember there's 2 of those. So we have a top and a bottom. So we have 2. Well, it's going to basically be the area of the square minus the area of the circle. So the area of the square is 30 times itself, 30 times 30, which is 900. The area of the circle is pi times the radius squared. So it's 2 of those 900 take away 100 pi. So let's see what that comes out to be. So we have 2 parentheses 900 take away 100 pi parentheses equal. So I'm getting about 1171.68. So that was for the top and the bottom. So we got the walls, we got the top and the bottom. But then when they say the surface of the ice cube is any part that would get wet, now we also got to think about the inside. Like if you were to put your finger inside and feel the smooth wall around that cylinder, we also need to get the cylinder lateral area. So the last thing we're going to find is, this is the inside of the cylinder wall. So we need that piece. And we always know that that's circumference times height. So our height's 15. The circumference is 2 pi r. So 2 pi, or what was our radius? 10. So when I do base times height, I get 20 pi times 15. 20 times 15, so that's 300 pi. Which is... And I think I might have put the wrong answer on the sheet, so double check this one to make sure that it is the right answer. So 300 pi equals 942.477. 942.477. And now I got to add up all those. So I'm pretty sure I screwed up on the answer key on teacher made. 0.68 plus 942.477 equals, I think it's 3914.157. So that would be just straight up 3914 for the surface area. So I think I messed up when I did this one. I think I screwed up. I used 10 instead of 15 for the height. So be careful on this one. That one, it might have said you missed it when you really didn't. All right, we did some of these in class. So I'm going to go a little bit quicker kind of through here, but here's the main concept. You find the volume of the brick, which is length times width times height, which was 600. You find the volume of the water in the tank, which is 20 times 10 times 15, which is 3,000. And what you got to think about is when you drop this 600 in there, we don't have 3,000 anymore. We now have 3,600 because we had the 600 from the brick. And our height is no longer 15. Our height is, I don't know, because the water is going to go up. So think about solving this equation down here, that I know that my volume is length times width times height. And I know the volume's got to be 3,600 after I put the brick in. The length is still 20. The width is still 10, but we don't know the height. So we got to solve this. So 3,600 equals 200h. Divide by 200, divide by 200. And we find h is 18. Now, that's not the answer because it says, by how many inches does the water rise? So we need to kind of look at what it used to be. So we went from 15 up to 18. So the answer is it rose 3 inches. So that's how much we went up. There are other ways to do that problem, but I think that one is the most straightforward. So similar idea for number 2. I'll go a little bit quicker. So we find the volume of this thing, find the volume of this. Well, the bottom one is 30, so I think that's going to be 9,000. Just double check my notes here. Well, I didn't write it on my notes. But I think it looks like, yeah, that'd be 9,000. And the pyramid, volume of a pyramid, so we got to do 1/3 times the base area, which is a square, times the height. So 1/3 of 15 is 5 times 144, which is 500, 700, 720. So you're 720. So I no longer have 9,000 in here. I have 9,720. And I now have a new h because it's going to go up a little bit. So same thing as before. The volume, the new volume, is length times width times the new height, which we don't know. And so that's 450h is 9720. Divide by 450. Divide by 450. 9720 divided by 450. 9720 divided by 450. 21.6 is the new height. Now, we were at 20. We're now at 21.6. So we rose 1.6 inches would be the new answer. All right. Find the length of the longest rod that can fit inside each shape. So these are all Pythagorean theorem type problems. So the longest rod that could fit here, that length, is just Pythagorean theorem. 6 squared plus 8 squared equals L squared. I know 6, 8, 10 is a Pythagorean triple, so I'm just going to kind of skip forward. Say the answer is 10. On this one, we kind of have our triangle right there. And we have 15 and 20. So we have 15 squared plus 20 squared equals L squared. You guys are pretty good at Pythagorean theorem, so I'm not going to go through all the steps. But once you set that one up, you get an answer of 25. All right, part C. Let's scroll this up here. Says a rectangular box with a 12-inch length, 9-inch width, 8-inch height. So we're trying to find the longest dowel or rod that can go through there. So I'm going to go from the front bottom right corner to the top back left. So I'm going to try to do that piece. And if I want to get that diagonal, I could imagine that there's a triangle sitting inside this box, like maybe a plastic triangle sitting right there that would actually be 90 degrees. And I could do the Pythagorean theorem. So actually we're trying to find L. Right now, I know that this leg over here is 8. But my problem is, and I'm just going to call it X, right now I am missing this bottom leg. I don't have that. So right now you got to kind of imagine with me for a second. Visualize that you are looking down inside the box. So this is a top view. So the top view, I'm looking down inside this box, and this box is 9 by 12 on the bottom. And I see that blue line cutting across corner to corner. All right? This blue line right here is the same as this blue line right there. All right? Or maybe I even make it red so it kind of stands out. That red line is really that red line. So I'm going to call it X. So I think I can, so basically I have a little right triangle right down here that I'm looking at. So there's my little right triangle. So I'm going to kind of double Pythagorean theorem this. So let's go ahead and do the Pythagorean theorem over here. And actually I recognize this one because I know there's a Pythagorean triple 3, 4, 5. And just kind of peeking at this, this looks like his big brother. If you times by 3, you get 9, 12. So I'm going to kind of cheat and not do the Pythagorean theorem. I know it's 15 because of that triple. So then when I come over here and I actually look at the blue triangle, I now know that this is a 15. So we have 8, 15, and then L. So 8 squared plus 15 squared equals L squared. And this is actually another triple that I'm familiar with, but I'll just work it out. 64 plus 225 is L squared. So that's 289 is L squared. And take the square root of both sides. Boom, boom, boom. And this one comes out to be 17 is the final answer. So there's 3 triples that I have memorized. I have the 3, 4, 5. I have the 5, 12, 13. And then I have the 8, 15, 17. Those are the only, those are the unique combinations. Well, then you can kind of go, like if you double these, you get 6, 8, 10. If you triple them, you get 9, 12, 15, and so on and so forth. So you could kind of go through and put some doubles and triples, but the ones that I see the most on the standardized tests are 3, 4, 5, 6, 8, 10, 5, 12, 13. If you could just remember those 3, I would say 90% of all problems on the SAT that involve Pythagorean theorem, you wouldn't even have to do if you could just remember those 3 combinations. All right, last problems down here at the bottom. What is the largest possible volume of a cylinder that fits inside this rectangular box? And round the answer to the nearest whole number. So we're looking for volume of a cylinder. So first thing I want to understand is the formula. Volume of a cylinder is the base area, which is a circle, times the height. So that's my formula. Well, now let's kind of focus on the actual cylinders themselves. Well, I could put a cylinder in the top of this box going straight down like that. That could be a cylinder that could fit in there. Now, to find his values, I would have to find the radius. So the radius of this is exactly half of the box, so that would be 6. And the height of this thing would be 10. So I could crank that out. I could do pi r squared h, and that comes out to be 36 times 10. So that's 360 pi. I'm going to wait to get the final answer until I do all the cylinders. So then I only have to do the biggest one in terms of pi. Well, the other way you could do it, and this one isn't very interesting, because if I did this to here and went that way, it's the exact same because these two are both 10. So this still has a height of 10, and the radius is still half of that, which is 3. Why did I put 6 in that first one? Screwed that up a little bit. It's not a 6, that's a 3. Whoop. So that would be 3 squared times 10, which would be 9 times 10, which would be 90 pi. So check that. That is 90 pi. But this cylinder is also going to be 90 pi because it's got the same radius and the same length. So I have number 1 is 90 pi, number 2 is 90 pi. Well, the third cylinder we could do could come at it from the side. Like I could put a circle, since this is 10 by 10, I could fit a circle right there, and then another one on the back side, and connect them, and I could fit a kind of fat cylinder in there, and this fat cylinder is going to have a radius of 5, half of the 10, but then its height, the distance between the bases, is only going to be 6. So I got to recalculate him and see how big he is. So volume is pi r squared h. So a fatter radius but a smaller height. Let's see what happens there. So that's pi times 25 times 6. Well, that's a lot bigger. That's 150 pi. So this dude right here is definitely the biggest. And if we want to know to the nearest whole number, 150 times pi, I believe, comes out to be 471.2. So 471 would be our final answer. Same idea. All right, last one. Let's kind of bust this one out really quick. So again, I have three different options, and this top one, if I kind of come in from the top and I kind of do that and come down, well, that cylinder has a height of 8. But the two dimensions on the top are 16, and then I got 12. So if it's 12 all the way across, it looks like I could do a radius of 6. So that would be pi r squared h. So there's that one. Let's try another one. If I kind of came over here on the end, well, the end is 8 by 12. Those are the dimensions. So that 8 kind of limits how big my circle could be. So it looks like my circle could only take up the whole 8 right here. It won't fill up the whole 12. And if 8 is the limit, then that means the radius is going to be 4. And my height is 16. So that one's going to be pi 4 squared 16. And then if I do my last one's going to go from the front here. So I have 16 across by 8 tall. So I'm still limited by that 8. So I'm going to have a radius of 4. So then I'd have another one in the back. And when I do this way, 12 is my height, 4 is my radius. So pi 4 squared 12. Well, right away, this one is out because this is the same one, but it's got a 16 here. So I really got it whittled down between these two. So let's just punch these in the calculator. So pi times 36 times 8 equals 904.77, aka 904.8, aka 905. Let's try the red one. The red one is pi times 16 times 16. So pi times 16 times 16 equals 804.24. So you are smaller. So the winner is 905. I am pretty sure I messed this up on TeacherMade. So double check that very last problem. It probably said you got it wrong, even though maybe you got it right.